When looking at streams and how they're formed and how they're shaped, the first thing I like to do is just look for areas of deposition and areas of erosion. One really neat thing to kind of look at when you're up at the top of a stream bank is the stream's plan form, or how it looks as it meanders across the landscape. Is it very sinuous or is it very straight? And you can see all kinds of areas of where sediment is being deposited and where it's being eroded. And that itself kind of forms the shape of the channel and has huge implications for forest management, riparian management, and wildlife habitat. One really cool example that I'm going to see in here, the inside meander bend of this stream is called a point bar. If you look at the very top, there's a very thick deposition of sand right on top. So again, when you're looking at deposition and erosion, it's all about stream velocity. So when the stream gets up and exits its banks on the floodplain there, the velocity drops very, very quickly. And what that means is it's going to immediately drop its heaviest sediment load, that being sand. So a lot of times along streams, we see this natural levee, a little bump of very, very coarse material before it moves out and the material gets very, very finer and the drainage poorer as you move back from the stream bank. So that really determines what species can live, and it's a big gradient between the top of the bank and back into the floodplain. That has a lot of implications for forest management and what species you should be thinking about. So again, highly, highly variable soils and floodplains. It's both a blessing and also a challenge for forest management. On the reverse, you can't see, but there's a huge cut bank right here. It's a source of erosion. The stream is perpetually moving this way, this way, this way. And when this material erodes, it's going to move downstream and get deposited on that next point bar.
The diversity of processes in the stream that Billy talked about are the same factors that create a diversity of niches and other environments that are responsible for all the biological processing that goes on in stream banks, streams and riparian systems, like water quality, flood retention, and wildlife habitat. And so in this stretch here, we see a sequence of what wildlife biologists call pool, riffles, and runs, which is where many aquatic organisms are adapted to life. And we also see overhanging vegetation, adjacent vegetation in the floodplains, and all of those things create the environments that make riparian ecosystems so important. Riparian forests are really important for Iowa's wildlife. They're our most common forest type across the state because it's an area where even prior to European settlement and then today, we just don't tend to see many disturbances there, like historically fire or grazing, and today like crop or development. And so we have a lot of riparian forests in the state, and wildlife are really adapted to those areas. Here on this riparian forest that we're exploring in the field day, we see a lot of interesting things going on. What I think is the most remarkable is right behind me here in this cottonwood tree is a nesting colony of great blue herons. And so these are what we call colonial water birds. They all nest in a neighborhood together in a tree, and they'll be up there for the next 40 days or so, building their nests, laying their eggs, and then raising their young before their young are ready to jump out and go feed on wetlands and lakes in places where you probably are more accustomed to seeing great blue herons. While we've been exploring out here, we've seen a lot of other wildlife and signs of wildlife. We saw a nest of a Baltimore oriole left over from last year. We saw an actively nesting red-tailed hawk. We saw a crow's nest. We saw swallows starting to construct their nests in the steep eroded banks in one of the meanders that we were exploring earlier. And then of course there's aquatic life all over riparian systems, living in the streams itself, in different areas, in pools or behind log jams or in rocky areas, and then in ephemeral or short-term or short-lived water sources in the floodplain. So we found an oxbow area that wasn't wet today, but surely during snowmelt or during periods of high flow, water gets into it, and it can be an important area for reproduction of reptiles and amphibians, or even some fish use oxbows for parts of their lives. So different types of riparian forest attracts different types of wildlife, but riparian forests, because of the integration of the terrestrial environment and the aquatic environment right together on the landscape, tend to be really productive and hotspots of wildlife diversity in Iowa.
I want to stress the importance of properly functioning floodplain forests and also the connection between the channel and those forests. When the channel is allowed to regularly flood these areas and these floodplain forests and well-managed riparian areas, it does wonders for water quality, water quantity, and also wildlife, aesthetics, timber value, and all the great things that are associated with these areas. As the water gets up and is able to access this floodplain, the velocities drop dramatically in the flow due to these upright stems of the trees. That allows for sediment to fall out. A lot of times phosphorus is associated with that sediment. The water that's left over, pooling and oxbows and little depressions, those are areas for denitrification and nitrate removal. Trees have many benefits to water quality when they exist on stream banks. If you start even from the roots down here, those roots add tensile strength to the soil, so really prevent that fluvial erosion from washing the banks away. Another cool thing they do is roots, they draw moisture out of the soil as the tree transpires. Removing moisture from the soil really helps add soil cohesion, again, preventing that water from washing it downstream. When roots grow, those fine roots, as they enter the soil, as they cycle carbon into the soil and all the other microbes and exudates of the roots, that adds to soil aggregation, again, adding to soil cohesion and lessening the chance that these banks are going to be eroded. Another neat thing too is when they do hang over the stream, they shade the stream and cool the stream temperature, the stream water temperature. This prevents those wild temperature swings from day to night if it was open, and that can have an influence on those wild DO swings as well. A lot of times folks ask me, what the heck is going on here? We've got this very tall, very erosive stream bank out here, and what the heck can we do with it? And to think about why this is occurring, you got to kind of think back to the alterations we've done to the landscape and to our stream channels throughout the last 150 years. We've changed land cover from prairie and forest to row crop, urban, parking lots, so things that have lower ability to soak up rainwater and deliver it slowly to the stream. Another thing we've done is we've straightened our stream channels, which increases stream slope and really increases the power of that water in the channel. So we're getting a lot more water in the channel all at once, and the stream here is just responding to that. It has to accommodate that new flow. So it's getting deeper and it's getting wider. And what we see often is these massive, very, very tall eroding stream banks. Besides height, the other reason this is eroding is because it really lacks vegetation. It lacks vegetation on the bank and it lacks vegetation on the floodplain. That leads to a very susceptibility to erosion. A lot of water quality and quantity issues we're experiencing here in Iowa are the result of the altered hydrology we've put in a lot of our watersheds. We've talked before about slowing the flow. A lot of these systems are very, very flashy. They respond very rapidly to precipitation events. And if you look the next time you're walking in a riparian area, you could see debris above your head or even higher. That represents the last flood stage. So you can imagine the amount of power in that flow. So any way we can do, any practice we can do to slow those waters down is going to really enhance water quality and downstream flooding, mitigate downstream flooding. Trees and floodplain forest establishment, management, and protection are an excellent practice to do that. They're not the end-all, but they are a critical component. Tree leaves intercept rainfall, saving that amount of volume from entering the streams and allow it to evaporate later. The stems themselves are critical. This upright, rigid stem really reduces velocity and encourages sediment deposition in our floodplains, phosphorus as well attached to that sediment. The roots act to increase the infiltration capacity of the soil, or how easily that soil can soak up rainwater and then deliver it slowly to the stream through shallow groundwater. So trees, forests, forestry, especially in floodplain areas, really do good to enhance our water quality and flood mitigation in the state. As you dig into riparian soils, especially in riparian forests, you'll see a good deal of sediment deposition. Again, these upright stems really slow the velocities down and encourage deposition of sediment and phosphorus into long-term storage on the floodplains and keeping them from exiting our watersheds. That soil sample I showed, if you look back, it's almost like looking at tree ring growths. You can see individual flood events and how those trees have slowed the velocity and trapped that sediment and attached phosphorus. Active forest management in floodplains is very challenging. You're dealing with a very dynamic environment. We've got highly variable soils, both laterally and vertically. You get fluctuating water table levels. You're getting flood events every spring and throughout the summer. But there's a high potential for timber value and timber production here, amongst the myriad of other things we'd seen today. In these dynamic environments, planning and persistence are key, and a little bit of luck helps too. So it all starts really with working with your district forester or private forestry consultant, any professional forester. There's programs like CRP and EQIP and REAP out there to help you in these environments. But again, persistence pays off in these dynamic environments, and it starts and ends with working with a professional forester.
Management of wildlife and wildlife habitat in riparian forest systems can take many forms. The most common challenge that faces wildlife habitat in riparian forested areas is invasive species. Like you can see behind me, it's almost just a wall of exotic honeysuckle. And riparian forest systems are really vulnerable to invasion by exotic species because the frequent disturbances that come in create bare soil and create ideal conditions for annual plants and then succession of many exotic perennial plants. And then also the floodwaters bring exotic species with them. So upstream neighbors may have invasions or come out of landscapes or something like that. And many invasive plants first show up in our floodplains and then start to create problems elsewhere. So riparian systems can be really challenging for that. So we encourage forest landowners to look for areas to improve wildlife habitat and also timber production and other ecological functions in forested riparian areas by controlling problematic invasive species like this honeysuckle and then a litany of others. Just walking out here today, we've seen European buckthorn, autumn olive, Japanese barberry, garlic mustard, and honeysuckle, all growing in this floodplain forest, and in some cases creating real problems with understory vegetation or areas where animals may ordinarily forage or nest, or just making the system less resilient. And so management in those environments can be really important. Other ways that you can manage for wildlife in riparian forested areas includes like protecting unique features like dead trees can be really good, important wildlife habitat. Or nesting spots, like the heron rookery we looked at earlier. We'd want to protect the trees around that rookery and make sure that those herons can come back to it for as long as they want to come back to it. And then also holes in trees, cavity nesting birds and many other mammals and even some reptiles will use holes in trees. And so protecting trees that have cavities, either created by woodpeckers or by broken branches, can be a really important way to create riparian forest wildlife habitat.